Hello, welcome to geometry. If you look over here, you have my beautiful drawings of my birdies. Here, we are doing lesson 66. If you notice, all my fingers are dirty. These videos take forever, so cut out some slack if you think our videos are very lame or cringy. They are. We're talking to nobody from the whole class, so just bear with us. For this lesson, this is dealing a lot with triangles. It's dealing a lot with finding area and perimeter of regular polygons. You think it's easy, it can get a little tough. You just have to make sure you examine every word in the formula, if I can give you that big hint, because it's not just base times height, 1/2 times base times height. It's a little bit not more complicated. You just have to pay attention. Here, regular polygons, that means all the sides are congruent. All the sides, if one side is 5, all of the sides of any type of polygon has 3 sides or more. So it could be an octagon, it could be a hexagon, etc., etc. So here, we have a perimeter of a polygon. We're going to start with that first. Here, we have P equals N times S. P is your perimeter. N is considered the number of sides that shape has. And S is the length, so it's number. So here, example 1, we have the shape here. Everything on this board is on the book. Also for your homework, 1 week I'm going to do worksheet like the week before we did worksheets. This week we're going to do lesson practices. We need to keep on doing the work, because before you take that quiz, some of you are just kind of guessing, you're not understanding because you're not doing the work first. Do the work first and then take the quiz. If you take the quiz without doing any of the work, you haven't had the practice to take the actual quiz. Again, we are recording these grades. I am looking at it every day to see if anyone's doing the quiz. I have a list. So if you know that you're not doing the quizzes, your name's on my list and we're trying to get in contact with your parents. Here, example 1, we have a shape, the 1, 2, 3, 4, 5, 6. It's a 6-sided shape. Here we're going to find the perimeter of the polygon. So according to the formula, which I'll always write, every time you're doing an equation, always write down the formula first, because then you can see what steps you have to take after that. Here, P equals N times S. I know for my perimeter to find that, N is the number of sides. I already said before that this has 6 sides, so N times S. Number of sides, which is 6, times the length of the sides, which is 3. Now my perimeter is 18 feet. Not 18 feet square, not 18 feet cubed. Also for your test, don't write the arrow 2 or the arrow 3. Just leave it as 18 or just as 18 feet. I don't want anything a little bit extra. I do go back to the quizzes, and if you have the right answer, but it says it's wrong because of the little arrows and it doesn't look like the answer, I go back and check every answer that you've written, and I if I see if it's right, I'll put the 25 points for that question. So don't think, oh, if I put this number wrong, or if I make one mistake, just putting one letter wrong, it's going to be wrong altogether. It won't. Here, example B, we have another sided shape. So here it says P is equal to N times S, number of sides times the length. S is the length. So here, 1, 2, 3, 4, 5, 6, 7, 8. I have 8 sides. That's my first number. Times the length of the sides. In this case, it's 2.7. So now you're multiplying the 2 to find your perimeter. Your perimeter is equal to 27 cm. Or 27. So it doesn't matter either or for your answers. Before we discuss area of a polygon, since they are regular, it's different. It's not just a normal formula like the square and the rectangle. Here, to understand about the polygons, especially as they get bigger, the pentagon and the octagon and the hexagon, there is a little triangle that makes all of these shapes. So for example, this has 6 sides. There will be 6 equilateral or isosceles triangles inside that shape. Because it's regular, there's going to be triangles for all of these. So the hexagon, the octagon, the nonagon. So all of that, they will all have small triangles inside the shape. Also, on top of that, there is a line that starts from the center of the shape and it goes all the way down. It creates a perpendicular line, meaning 90 degrees. It's called an apothem. That's kind of like your height, not really your height because your height will be the whole shape. It's the height of the triangle inside your shape. Here, a couple things about triangles. When we're trying to look for that one small side, we always go back to Pythagorean theorem, which is a squared plus b squared plus c equals c squared. So this equation here will show you how to solve for a missing side. We've learned that there's not only one way to solve for it, but there's 3 ways altogether. So that worksheet you did in the beginning, that day you came to class on Tuesday, I recommend you doing those worksheets, because now 30, 60, 90, 45, 45, 90, we're dealing with these triangles for this lesson. 30, 60, 90. Our first thing about this is you're always trying to look for your small side first. Your small side is always across from your small degrees. So 30 degrees, it's across from it. That's your small side. Next one is the large leg. The large leg is across the 60 degree. 60 degrees right here, it's across from it. The equation for that is large leg is equal to the small leg, which is x, times radical 3. Your hypotenuse is double the size of your small leg. Your 45, 45, 90, your legs are congruent, meaning they're the same size, so x and x. Your hypotenuse is your leg times radical 2. And those are the 3 ways to find the missing side for the triangle, because since we have triangles, we're always going to look for the apothem. That means we're always going to look for that long side. It could be a short leg, it could be a tall leg, it could be anything, we don't know. So this is the equation. Area is equal to 1/2 times A, lowercase a, times P. P is your perimeter, A is your apothem. It's not your side anymore. So now when you look at these shapes, you can't just think, oh look, I have a side of 10, I have to multiply 10 by something to get the answer. That's wrong. Lowercase a is your apothem. It's your height of your imaginary triangles inside those shapes. Example 2. Here it says find the area of the shape if the apothem is 18. So we don't have to create any triangles. We don't have to solve for anything, because we have the 2 things we need. We have the side and we have an apothem. According to this, area equals 1/2 times A times P. You're always going to look for your perimeter first. Your perimeter is the number of sides times your length of the sides. So 1, 2, 3, 4, 5, 6, 7, 8. It's an 8-sided shape. So I have my 8 there, times the number of sides, which is 15. So I have that there. Actually, I'm going to erase this. Didn't realize I need more room. And that will give us the perimeter being, what was this example 2? 120. We're not done there. Now we have to apply this formula. A times 1/2 times your apothem. Your apothem, just kidding. Apothem is your number right here, which they told you in the beginning. That's the good thing about example 2. They told you. So it's 18 times your perimeter, which was 120. So it's not 10 again, or 15. You're not multiplying 15 again. It's your apothem from what you started in the beginning. So now you multiply all that together, and you end up with 1,080 inches squared. So on your test or on your quizzes, if you need to put the squared, just leave it as 1080 inch or even 1080, and I'll accept those too. I try to put in the arrow, but even if you do like 1 space, it counts it completely wrong. Again, I go back and check the answers. Next one, example 3. Here we have the shape here. It's going to be, oh, I didn't draw my triangles for this one. Oh, I did. Example 3 is up there. Oh, ow. Right there. So now we have example 3. We have the shape here. We have to find the area. So here, according to the area, I always write it out. I have the shape here. Don't look at this just yet. We're going to look here. Area is equal to 1/2 times A times P. That's the equation of the area for this. I know that I have to start with my perimeter first, so we'll do the easy things first. Perimeter is the number of sides times the length of your sides. In this case, 1, 2, 3. It's a 6-sided polygon, so I'm going to put 6. The length of the sides is 10. So my perimeter is equal to 60. That's your first step. The second step is including this all together. We don't have our A. We have to find our A. Our A is the height of the triangle inside the shape. If you look at this shape here, it creates a triangle. If I were to draw that triangle out, I have this right here. I'm just going to erase all of this here. We have a triangle like this. We don't have a degree. We know that this is the apothem, and I have to go solve for that. I know that this whole base is 10, so that means if I'm drawing just one part of the triangle, that side is going to be 5. Here, we have to solve for it. We can't use Pythagorean theorem over there because we don't have two of the sides. We only have one side that's known, and that's the base right here, and that's 5 because that's half of this side here. We're only looking for this half of the triangle here. So here, if I were to look at this triangle, we only have sides, but it shows no degrees, but I know for my center here to find the number of degrees, we have a six-sided shape, therefore there's 6 triangles inside the shape. So that means to find each of the degrees of the triangle, so each of these marks right here, what you do is you do the 360 because that's what all angles equal to. So you do the 360 divided by the number of triangles that you have here. We have 6 triangles, 2, 3, 4, 5, 6, and therefore we end up with 60. So that means the measurement of this right here is 60. So you look at this, we don't have anything given to us, we don't have any degrees, so therefore we have to think outside the box. We have triangles here. We know that there are the same number of triangles as sides. There are 6 triangles in here. So that means to find the measurement of each of the corners right here, we have to divide it by the number of triangles. That's 6. That means each of these is 60 degrees right here on the top part right there. Now, if I were to redraw this again, I have the half triangle here. I have this as being 5, right? Because this whole thing is 10, but we're only looking for half of it. We're trying to find this length right here, which is this length right here. I know that this whole thing is 60, but keep in mind we're creating an apothem and it cuts that line, it cuts that angle in half. So when it cuts that angle in half, if this whole thing is 60, this side is 30 and the other side is 30 as well, because it cuts it, it bisects the angle right there. So this angle altogether is 60, but when you create the apothem, it makes it 30 on one side, 30 on the other side. So that's why that is 30 right there. Let's just make this better. 30. Now we have a 30, we have a 90. That means it's a 30, 60, 90 triangle. Now we have to go back from what we learned. So I have this here. Go back to your worksheet. This 30 is across from the 5. So that means their small leg is equal to 5. What we're trying to find is this side right here. So we don't have to look for all the missing sides here. We're only looking for just one side, and it's the apothem. Now, to find apothem, I know that 60 degrees is across from that side. So that means this is my large leg. I know that the formula for this is your small leg times radical 3. I'm looking for that side, so I know it's the small leg times radical 3, or x. And I know now, looking at this side, that my small leg is 5. So it's 5 times radical 3, and that's it. So now your side, your missing side, if I put a here, is equal to 5 radical 3. Going back up here, this side right here is 5 radical 3. So that's 1/2 times 5 radical 3 times 60. And you multiply that all together. Half of 60 is 30. 30 times 5 is 150. Radical 3, I believe this is centimeters squared. And that's your answer. Last one, and then we're done. Here, example 4, we have an equilateral triangle, 18, 18, 18. Here we have an apothem. This is your lowercase a. We are trying to find the area of the shape. First thing you do, you always look for your perimeter first. Number of sides, there's 3 sides, it's a triangle. The side lengths are 18. That means your P is equal to 54. Now we have to find our area. That's 1/2 times your apothem times your perimeter, which we have, which is 54. So for this, I'm just going to put parentheses because we need to find what that is. Looking at this, it creates another triangle. Here they gave us some degrees, so it makes it a lot easier. We need to find the apothem here. That's the height of the triangle. I take this triangle out and I examine it. I know that the bottom, the base, is 9. They tell me here in the picture that this is 30 degrees. Keep on looking at this picture. Now I have to examine even more. It's 30, it's a 90. This has to be 60. Another thing, it looks like a 30, 60, 90 triangle. Therefore, the opposite side of 30 is a small leg. The opposite of 60 is the large leg. So we have our large leg, we don't have our small leg. That goes back to one of the 3 formulas that we use. Now, here, what we're trying to find is this length right here. We're trying to find this length right here. According to the large leg formula, so if I go back to the formula, small leg is equal to x. To find the large leg is equal to the small leg times radical 3. That means to find your small leg, that's what x is. To find your small leg, you're going to have to divide both sides by radical 3. And to find your small leg, it's going to be equal to the large leg large, divided by 3. So here I have my large leg. So that means the only thing that's given is a large leg. So I'm going to use a large leg formula. So large leg is equal to small leg times radical 3. I have what my large leg is. My large leg, there you go. Can you see it? Move over here. So my large leg is 9, and that's equal to your small leg. I'm going to label it A, because that's what we're trying to find, and it's called a possum. A times radical 3. To get the small leg by itself, you multiply both sides by radical 3. 9 radical 3, radical denominator, you cannot have that. Multiply the bottom, multiply the top by radical 3. Then you get 9 radical 3. Radical 3 times radical 3 gives you a whole number 3. 9 and 3, there's a common number. 3 can go into 3 once, 3 can go into 9 3 times. And you get 3 radical 3. Now you have what your A is. 3 radical 3. And now, 1/2 times 3 radical 3 times 54. You multiply it all together and you end up with 81 radical 3 inches squared. If you need more help, go ahead and email me down there. I will have homework assignments. Make sure you're doing the lesson practices for this week. Do not take the quiz unless you've done the lesson practice. This can get complicated. Just go back to that worksheet in the beginning and work it out. Try the best you can. Go back to that worksheet. I don't know how many times I can say that. I love you guys. Miss you all.